Hi, do you know what it's time for? Calculus! What? Okay, so I need you to bear with me for a minute and not be scared of this because really the stuff that I'm showing you at the first part of this video is something that you do not need to memorize. You don't even need to reproduce, but I need you to work with this later just so I need you to have some faith in me that where this stuff comes from actually is mathematically sound. So go with me on a little journey and this will be great. Okay, so this first part of this is a double angle identity. And do you need to memorize this? Nope, not so much. Should you write it down now? Yep, just so you have it. You actually might use it in Calc BC or Calc 2 later, but we don't use this here. You will only see this right now, and I need to use it to convince you of the validity of this next thing that we're going to do. Okay, so up till this point, whenever we've been doing the derivative, also known as, the slope of the tangent, every time that we've done that so far, it hasn't been with trig functions. But today is your lucky day because we're going to use trig functions. What? It's actually not too bad at all. Okay, so we've got this big limit definition, limit as h approaches 0, just as we moved away from it before, now we're coming right back. And now I'm going to say, what is the function value, or not function value, I'm sorry, if f of x is sine of x, and I'm putting this whole mess into that formula, what do I do? So I'm going to say the limit is h approaches 0, f of x plus h will be sine of x plus h minus sine of x over h. Easy peasy, lemon squeezy. So then the next thing that you're going to do is you're going to be like, okay, well, it can't be quite that easy because I actually don't know how to simplify that in any way. I can't factor anything. So what do? The next thing that you do is you have to use this double angle identity, sine of a plus sine of b is equal to that whole mess. So I'm going to write limit as h approaches 0. And instead of sine of x plus h, I'm going to write sine of x cosine of h. And I could put parentheses every time around here. There we go. And then that was like x and h plus cosine of x sine of h. Okay, so that's all from this mess. And then I would have minus sine of x. Whew, you're going to gain so many friends if they watch you do this. Sine of x all over h. And now we're going to do some little bit of algebraic manipulation. And I'm going to say, you know what, this is the limit as h approaches 0, but anything that has a sign in it. So I'm going to take my sine of x and I'm going to move this around a little bit. So I'm going to say sine of x cosine of h. And yes, these could all be in parentheses right now, minus sine of x plus cosine of x sine of h. Bear with me, I just reorganized this mess down here. Because what I want to do next is I want to factor out this sine of x. And do you see how this I would be left with cosine of h minus 1? Okay, that kind of looks like something I did before, so keep going. And then I'm going to take this plus cosine of x sine of h. And if you're still following me, thank you very much for doing so. I hope that you are, at least so that you can be convinced that this is like an actual thing. This is the long way of doing it, but we're proving f of x is sine of x. I want to know what the derivative is, so I'm doing this long definition of the derivative, the formal definition. And then I'm going to split this up. So you see how I've got this sine of x here? I'm going to say sine of x. And then this stuff I'm going to split up because I can make this just a fraction. So I'm going to say negative 1. So I'm going to factor out a negative 1 and I get negative cosine h plus 1. If you're like, where are you going? Just stick with me for a little bit. I'm factoring out the negative 1. And then I'm going to say plus cosine of x sine of h. But instead of just dividing everything by h, what I'm going to do is I'm going to separate this into two, because just like you can add as long as you have a common denominator, if the numerator is added in any fraction, you can separate it into two parts as long as you have this common denominator. So this is a perfectly legal move. And now I'm going to do some more math magic. I'm going to say, I'm going to split up the limits even more, because I could say sine of x over 1 times this whole mess of a fraction. So I'm just going to split this up and say the limit as h approaches 0 of just sine of x. The limit is h approaches 0 of this mess. And I'm going to rewrite this slightly, and you might be with me now. So I rearrange this, and so negative cosine of h plus 1, I'm rewriting it as 1 minus cosine of h, because now it should look like something that you remember a little bit, plus the limit is as h approaches 0, and I'm going to split this up also, times the limit is h approaches 0 as sine of h over h. Sorry, I know that's getting kind of yucky. There we go. So the reason why I'm doing all this, and I'm allowed to do this, oh, sorry, you almost saw that mess on the other side. You definitely did, but we're going to pretend you didn't. The reason why I'm splitting it up like this, do you see these two things are multiplied together? This is a perfectly legal move. I could get back to this. These two are multiplied together, perfectly legal move. I can just put this as a denominator 1, and I split up all these limits using the property of limits that we learned from last unit. The limit is h approaches 0. If I substitute in 0, I would just get sine of x. Do you remember that limit as x approaches 0 of 1 minus cosine of x over x? And that was one of the limits that you remembered, like that you memorized, that this whole limit was equal to 0. 0 or negative 0 is still going to be 0. Plus, because here's a plus, cosine of x, so limit as h approaches 0 would be cosine of x. And then I've got times the limit as h approaches 0 of sine of h over h. Remember, this would be like the same as the limit as x approaches 0 of sine of x over x, which this whole thing is 1. All of this to say sine of x times 0 would be 0 plus cosine of x. And if you stuck with me this far, you get 3 gold stars for the day. I don't have these gold stars. They're virtual gold stars, so twinkle, 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 twinkle. That's what gold stars sound like if they're being delivered to you. Or maybe I should say twinkle, 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 twinkle. You got them. So right here, this is the derivative. So really, the only thing that I need you to know from this entire thing is, one, I'm not making this stuff up, but the derivative of sine of x is cosine of x. Ta-da! And this is where, if you're like, I really want to know the rest of this, I want to know how you get the derivative of cosine of x, you can go through this whole process and you can follow my work and you can pause the video where you need to, or you can just say the derivative of cosine of x is negative sine of x. So this is the stuff that you really, 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 really need to know. All the rest is just for fun. Okay, so 9 minutes in. If you stuck with me, nice job. If you fast forwarded to this part, okay, let's go from here. So the derivative of sine of x is cosine. The derivative of cosine is negative sine. We did it. Keep on moving on. Now we can use that information. Fun fact, the derivative of any trig function like cosine, cosecant, cotangent, all of their derivatives are always negative. Crazy. It has nothing really to do with math there. It's just a fun fact. Okay, so you should be on page 58 now. No, 59. What am I talking about? 59. There we go. And now we have to use all the stuff that we knew before, and we can do shortcuts on any of these, but using that new piece of information, the derivative of sine is cosine, and the derivative of cosine is negative sine. So, in this first one, you could use the really long definition of a limit, but I wouldn't. I would say, well, I think this is, I could use the power rule somehow in this, but I can't the way it is right now. So what I need to do is, notice I'm labeling as f of x. I am expanding this. And now I'm going to say, you know what, I know f of x is equal to, and you can multiply these in any order, but I know x plus 1 times x plus 1 would be x squared plus 2x plus 1. And this is all f of x, so I'm labeling all of it. If I take 2x times x squared, I get 2x to the third plus 4x squared plus 2x, distributing this negative 1, negative x squared, negative 2x, negative 1, simplifying 2x cubed. This would be plus 3x squared. 2x squared cancel out, and I would just be left with negative 1. And so I do all this, and I'm just going to check it with old me and make sure I got the same thing. Hey, me in the past got the same answer, so I hope you did too. If you didn't, stop this. Calculus is really advanced algebra, so if you're like, I messed up somewhere and you need practice just distributing, do that now. But now that we've done all this work, now remember that power rule? Try it. Try to see what is the derivative. Check it with mine. Did you get the same thing? This one says then to find the equation of the tangent line to the graph at the given point. So it says when x equals 1. If you want the equation of a tangent line, you need two things. What are they? A slope and a point? Yeah. So the slope of a tangent line is always this thing, the f prime of x, but it would be at this particular value. So f prime of negative 1. If you substitute negative 1 in here, I would get negative 1 squared, which is 1 times 6. 6 minus 6 would be 0. And you also need a point. So f negative 1. And then you go back up to this original. So 2 times negative 1 is negative 2. Minus 1 is negative 3. And then this would be negative 1 plus 1 squared. So you'd actually get 0 on this also. This is boring. Y minus y1 is equal to m times x minus x1. If you want to just write this as y equals 0, you could do that too. But it's still a line. A lot of work. But we did it. Okay, let's do another one. So in this one, yay, we have f of theta, and it says 4 sine of theta minus theta. Okay, so what I want to do is I want to find the derivative. And the whole reason why I'm finding the derivative, by the way, is because I'm finding the equation of the tangent line. To find the equation of a tangent line, you need two things. Yep, a slope and a point. And the slope of the tangent line is the derivative. So we're finding the derivative. So here, we said, like the derivative of 4x, you know how it was just 4, and some of the other ones, even like ones like this over here, this would be the derivative of x cubed would just be 3x squared. But we would just keep the front 2 in front and then we multiply afterwards. If you have a coefficient with a trig function, just keep it with it. So the derivative of sine is cosine. And then this is actually the hard part. Let's think about this function, y equals x plus 7. So way back in algebra 1, what is the slope of this line? Slope of this line is 1, because there's really a 1 out in front of here. Same idea here, even though this is theta, and we don't usually think about theta, this slope is going to be just 1, and there's a minus sign in front of it, so it's going to be negative 1. Okay, so I do this to find the equation of a tangent line. I need two things. What are they? The slope and a point. So we've got this slope of the tangent line, also known as the derivative. So I'm going to find f prime of 0. Cosine of 0, the way that I think about this is I think about the sine curve, or the cosine curve in my head, I'm sorry. Cosine of 0 is 1, so I've got 4 times 1 minus 1. 4 minus 1 is 3. So now if I did this, y minus y1 is equal to m times x minus x1. I also know my x1 is just 0. And so all I really need to figure out now is my function value. Oh, sorry, my big head's in the way. There we go. F of 0 is 4 sine of 0 minus 0. I'm just going back up to the original function. 4 sine of 0, so sine of 0 is 0, times 4 is still 0, is 0. So we've got this one. Nice. Could put a little box around it. Put a box around this one. I kind of went into this space, but whatever. Okay, try the next two and then come back and see how did you do. So I'm going to keep going, but you try them, go back through this as needed. So in this one, to find the slope of the tangent, g prime of theta would be the derivative of 2 is just 0. the derivative of 3 cosine of theta would be negative 3 sine of theta. If I substitute in pi to find the slope of the tangent at pi, sine curve, this would 0 to 2 pi, so pi would be right here. This would be another 0. Boring, but we'll keep going. G of pi will give me my point since I need a slope and a point. So I've got 2 plus cosine of 3 cosine of pi. 2 plus 3 cosine of pi. I'm thinking about my cosine curve of pi, 0 to 2 pi. So halfway there would be at negative 1. 2 minus 3 is negative 1. So I get y minus y1, which would be negative 1, so I can say plus 1, is equal to m. My slope was 0. X minus my y, or I'm sorry, my x1 value would be pi. Okay, let's do another one. So I've got h of x, and I'm trying to find h prime, and then I look at it, I'm like, ugh, crap, what's this mess? You may not take the derivative of the top and the derivative of the bottom. Don't do that. Not even if you rewrite it, you have to make it into a single fraction. So the first thing that I'm doing is I'm going to rewrite this. Is I'm going to say this is 2x, this is x to the 3 halves. The reason why this is because I've got x raised to the 3rd power. This square root sign allows me to put a fractional exponent, like to divide by 2 in my exponent of the denominator. So I've got 2x over x to the 3 halves. Right now this is like 2x to the 1st power, x to the 3 halves, and just like you can say x squared over x is equal to x to the 1st, and I subtract my exponents that have like bases, I'm going to do the same thing over here and say this would be 2x 1 minus 3 halves. It's like 2 halves minus 3 halves, because this is 1 whole. That would be negative 1 half. Okay, so I did all this work, and then I'm like, now it looks like a coefficient times a variable raised to an exponent. So I can say h prime of x is equal to exponent times this. So negative 1 half times 2 is negative 1. X. Subtract 1 from the exponent. Yeah! Okay, and then I would rewrite this. Just because if you don't, when you substitute, is it a lot easier to make a mistake if you've still got a negative exponent. To find the equation of line, you need 2 things. What are they? Yeah, slope and a point. H prime of 2. H prime of 2 would be negative 1 over 2 to the 3 halves, which would be negative 1 over 2 to the 3rd power is 8. And then it would be the square root of that, which I don't know what it is, so I'm going to leave it like this. If you really want to change it, you can, but let's just get in the habit of being in calculus where we don't have to take a square root out of the denominator or rationalize this in any way. We get to do this now. It's very exciting. H of 2 is equal to 2 times 2 over, I'm going back to this original function, so this would be 2 to the 3rd power square root. So I would get 4 over square root of 8. And if you're like, this really bugs me, I want to reduce this in some way, because you know that you can take 4 and then in the denominator you could have said that this was equal to square root of 4 times 2. Square root of 4 is 2 root 2, and you really wanted to reduce it to that, you can. But I'm not going to. I mean, I already did, so it's kind of cheating. But I'm going to say it's okay to write y minus y1, which was just this crazy 4 over square root of 8, is equal to m times x minus x1. I'm so sorry for how many friends you're getting right now. When they see you doing stuff like this, they're going to be like, whoa, that person is so smart. And then you're probably, your social schedule, even during this time, is probably filled. So be careful. This stuff will make you so popular when your paper looks like that. I know, I have to like push people away because they're like, you teach math? I'm like, yeah, I do. And then they get really happy and they want to hang out with me. And I say, hey, give me some space. I have friends, don't worry. I'm not sad. Okay, but it's probably not because of math. So in this, given the equation of a function, you might determine the values at which a function has a horizontal tangent. Okay, let's think about what that means. Horizontal tangent would look like this. Think about the slope of that line. The slope of the tangent would be, it would be 0. So I want the slope of the tangent to be 0. So I would want the slope of the tangent to be equal to 0. And do you remember when the slope of the tangent, what other name I can call that? Yeah, the derivative. Or you can say f prime. So you set f prime equal to 0, then solve for x. Okay, so if I have this one and I want to know where we'll have a horizontal tangent, I find the derivative, and then I set that equal to 0. Solve this. Divide by 3. I've got negative 1/3 is equal to x squared, and then I take the square root, and then I'm like, I can't take the square root of a negative number. There are no values of x that f of x will have a horizontal tangent. Isn't that a little sad when you're doing it and you expect to find a value of x and then all of a sudden you're like, no, and then your hopes and dreams are torn from you? If you need to, if you want to come to office hours and get some virtual there's, I'll do that because that's a tough pill to swallow. Okay, maybe this one. Definitely this one. I'm looking for a horizontal tangent again, which means I need to take the derivative of this business, f prime of theta. You try it. Okay, now we'll do it together. The derivative of theta is 1. The derivative of sine of theta would be cosine of theta. If I want to know where this has a horizontal tangent, I would have 1 plus cosine of theta. And then I'm like, okay, what do I do? What you need to be thinking, I should move this up to where you can see it, is where is cosine of theta on the interval from 0 to 2 pi equal to -1? So when I do this, I think about, well, cosine curve looks like this. There's only one location that's at -1 between 0 and 2 pi. And that value is halfway there, which would just be 1 pi. So I would say theta is equal to pi. Ta-da! You're great. Thanks for listening, for writing, for learning, for asking me questions when you have them after you're done with this lesson. I think you're awesome, and I'm so lucky to teach you. Bye!